Toorcon for doing Ruby stuff with IDA. So, so who am I? I used to work on Metasploit, and that's pretty much my only famous. And yeah. So before I get started, I'd also like to thank Scape for helping with the original design of IDA and then everybody else who helped test it and gave feedback and stuff. And everybody who made Toorcon possible. So what is IDA or how many people here have even really, how many people here use IDA on a regular basis? That's pretty good. IDA is pretty simple. It's just an IDA plugin that embeds the Ruby interpreter into IDA and then allows access to the IDA SDK from Ruby. So it doesn't really add anything that's not already in IDA. It's just making it more convenient. And then the one thing it does do is expose it remotely, which I'll talk about. So the original plan was try to build like a friendlier SDK, but I haven't really done that yet. So anyway. So the first thing people are going to ask is like, there's already IDA Python, so why even care about doing Ruby? Python is really good, and I looked at it a lot when I was working on IDA Ruby. But I was just sort of doing this for fun, and I wanted to write in Ruby, and I wanted just to write this. And when we figured out how to do the network model and the interactive model, which I think is really important, and it's actually probably one of the most valuable pieces about it, and I only knew how to do it for Ruby, so instead of make IDA Python do the same thing, I just did it all in Ruby, and it wasn't that hard. So also, we have a lot of other tools that we've written in Ruby, so it would be nice if we could like have a common ground. But I guess all of the reverse engineering stuff is happening in Python now, so maybe it's a bad idea. But also, the plugin itself is probably a good example for how to write IDA plugins that act asynchronously. So one of the biggest problems with IDA that I'll talk about is that it's all single-threaded. So if you want to have any sort of interactive plugins and stuff like that, you have to do some tricks. So I'm kind of hungover, and this is really boring talk. Sorry. So yeah, another thing is I have Swig wrappers that I wrote that should be, I tried to keep the Ruby-specific aspects of it as small as possible. So if you wanted to use the same wrappings to wrap the SDK in Python or like Tickle or something, good. So even if you don't care about Ruby at all, there might be some useful pieces outside of that, the Swig wrappings and the plugins and stuff like that. So like, what were the original goals? So if anybody's written IDC, it's kind of like a bad language. And so I guess the goal was to get rid of IDC for like simple stuff. And there's no reason to ever try to replace like full normal plugins. And the most useful thing I found with IDA is just being able to interactively sort of play with IDA and figure stuff out. So I actually find myself using it a lot to prototype a plugin that I'll write in C or something. So I'll basically prototype it out in Ruby or sit in an interactive prompt and sort of figure out like what steps I'm going to go through, and then write the whole thing in C. So it's useful for that. Yeah. So one interesting thing about IDA Python is they have this big IDC compatibility layer. So basically all of the functions that you find in IDC are re-implemented in IDA Python. So it's pretty easy to port code that was in IDC to IDA Python. Although this is like 8,000 lines of Python or something to have this compatibility interface. And that's just a lot of work that I didn't want to do. So I don't have anything like that. So the technical details of works is kind of just engineering nitty-gritty details, but that's what I'm going to spend the beginning of this talking about. So it's going to be kind of boring, but I guess it's good to know. Also, yeah, the IDA was very difficult. I found a lot of IDA bugs and stuff while working on this. So it was basically like the concept of this is really cool, then actually making everything work was really complicated because it's just kind of a mess. But anyway. So if we want to access, so people who don't know, IDA is a disassembler, and they have a C++ API to allow you to automate stuff like add comments and do disassembly and all sorts of stuff. So if we want to access this from a higher level language, we need some sort of wrapper from the high level language to map the C++ interface. So you could even you could either write this by hand, which some people do, or there's this tool called Swig. And the nice thing about Swig is, at least conceptually, it tries to be decoupled from the language that you're wrapping it to. So you can write Swig bindings, and then you could use it from like Ruby, TCL, Python, blah, 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 blah. And it's a lot quicker to do. Although there was a lot of Swig bugs that I dealt with too and stuff. I have to sed my like generated code right now and search and replace stuff to make it compile. But anyway. So one of the things that I did differently than IDA-Python, because IDA-Python also used Swig, but what they did is they modified all of the IDA headers so that they would both compile and they used them to run Swig over them. So you have all of these headers that would sort of be like if def swig. And so can you, anyway. The light's like right in my eyes. Yeah, I can't see it all. So basically what I did is I just took two sets of headers. I had one set of headers that I was going to run Swig over. And since there's a lot of functions that Swig might not be able to wrap and stuff, I just completely modified that set. So I say like, okay, I don't need this function header up, I'll just remove it from the headers. So I basically had a cleaned up set of headers that I ran Swig over to generate the wrappers. And then I had the normal unmodified headers that I actually build against. So stuff that I can't do with Swig right now. Number one, IDA uses the same set of headers for both the public interface and for their internal interface. So there's functions in the headers that aren't actually exported in the DLLs. So Swig will try to generate wrapper code for that, and then it will be referencing function. So you have to remove any non-exported data or functions. Right now, I also don't support callbacks, so anything that takes function pointers, so a lot of like the user interface functions and stuff like that. So you have to remove any functions with callbacks, and then there's some other little things you have to fix up, like defines and stuff like that. So then the way Swig works is you end up writing these things called type maps, which are basically sort of pattern matching on the prototypes of the functions that you're trying to wrap, and then you can translate those into specific things. So I had to do a lot of specific stuff for IDA, because if you just look at a C API, it's not clear like what's an input argument, what's an output argument, and stuff like that. So there's a lot of targeted stuff. But in total, it was only 128 lines of Swig definition, so it's not too bad. And for a lot of the stuff, Swig is sort of a pain to work with. So I tried to defer most of the, I tried to defer a lot of stuff just to doing it in Ruby. So be like, okay, I'm going to wrap this function, and it's going to be kind of lazy, and it's not like, you're going to have to fix up the return values afterwards. But I'll just do that in Ruby instead of doing it in Swig. So then the actual part about embedding Ruby. So in order to do this, so I wanted to support both executing scripts locally inside of IDA and remotely. So I just embedded a Ruby interpreter inside of an IDA plugin. And there was a lot of tricky details about this, but it's interesting. So the way it works is the plugin dynamically links against the Ruby DLL. So you need a normal Ruby installation, but then that's it. And then the Ruby interpreter gets loaded the first time the plugin gets initialized, and then it just stays loaded. So the way Swig generally works is it's made to compile loadable modules. So you usually like compile like a .so or a .dll. So basically I took just the Swig generated code that would normally be a DLL, and I just compile it into the plugin. So you just have one DLL that has everything. So there's an IDA plugin with Ruby embedded, and then it has the Swig bindings also embedded. And then if you just wanted to do local mode, this would be all that you need. So this is basically what IDA Python is. It's just an IDA plugin with a Python interpreter and then Swig bindings. So local mode's pretty straightforward. And I thought the coolest thing about this, and I wish project, if we hadn't gotten to work, was the network access. So basically, what we did is you basically write a little RPC mechanism to access the SDK from outside of IDA. So there's something in Ruby called DRB, distributed Ruby, and originally I tried that just to create like a RPC mechanism. But there was tons of crazy problems with it. So I just wrote, it's convenient because since we're swig wrapping stuff, we basically know all of the types that we're going to be calling into functions are going to be really simple. Like I'm not going to have like an array of hashes of arrays or something like that, because I'm only calling C functions, so the mapping is pretty much like very simple. So I could write a very simple RPC layer just to marshal all the arguments, because none of them were complex. So then I actually just write a bunch of Ruby code, and then I just a string and put it in the actual C++ code. So the Ruby code for the RPC server is just also embedded in the plugin. And then the C code for the plugin is very thin, pretty much defers all of the work into the Ruby part, which makes things pretty simple. So then you just loop this, and you would have remote SDK access, but you wouldn't be able to use IDA at the same time. So this would basically be like you would have a server that would be non-functional, and it would just allow IDA access. Doing the RPC part in Ruby is fairly simple because it's a dynamically typed language and it has built-in like marshalling and stuff like that. So you can just sort of say, okay, I have this object, now I want a string representation of it, and I'm going to send it over the network and then unmarshal it on the other end. Although when you mix in the swig objects, it gets a lot more interesting. The swig objects are these lightweight C++ objects that get wrapped into Ruby, and then they basically just wrap like a pointer to an IDA object. So this isn't information that you could send across because it's all wrapping C++ data structures. So Ruby has no way of being able to inspect that object and like serialize it and stuff like that. So yeah, the RPC mechanism is just very simple. Like you send a request to call an API, and you get the response, the return value. So another concept that I stole from DRB is the idea of a front object, which is just when you initially connect to the RPC server, you need something to start calling methods on. So you get an initial object called the front object. So this is the starting point to call any methods. So basically, the way the protocol works is pretty simple. I just send an array that over an array on the network, which is the object that I'm going to call a method on, the name of the method, and then any args. And then I just get the return values back. And if there's any exception thrown, I catch the exception and send that back to you. So it's pretty simple. So you could support callbacks, although it makes things a lot more complicated. And the only things I initially looked at that needed callbacks were user interface code. And I figured if you were writing remote scripts in Ruby, there's no need to be using that user interface. So I didn't support callbacks at all. Okay, so one other engineering detail. So there's some objects that you can marshal easy and make sense on the client side. So for example, say I call an IDA function and it returns a string. I can just send over all of the data for that string and it makes complete sense to the client. So primitives, strings, integers, exceptions, these are all easy to marshal and they make perfect sense. But unfortunately with IDA and wrapping all of this stuff, there's all of these objects that won't make any sense on the client. So even if I could marshal like a swig object, you'd basically end up with the client having a pointer to some memory in the IDA server. So, and that is completely useless to the client. So this is pretty much the case for all IDA instances, classes, structures. And they would be difficult to marshal even if you could marshal them. And then you would also require the client to have knowledge of all of the constants and all of the classes and all of the class definitions and stuff right now. So the way it's designed right now is that the client is super thin and it doesn't have knowledge of like any of the IDA stuff. So you could basically reuse the client for something completely different than IDA. It's just sort of a generic RPC mechanism. So what you have to do is, so for types that aren't simple, like integers and strings, you basically client like a proxy object. So they just sort of get this thing that I call a reference object. So then they have this dummy little stub that just has an ID that correlates it back on the server side. So then when you call methods on this, you basically say, I'm calling method foo on reference object 1234, and I have no idea about it. And then the server keeps all of the objects. So this is just a way to proxy all of those objects that we wouldn't be able to. So basically the way this is implemented is when the RPC server calls a IDA function, it gets all the return values, and then it walks through all of the return values, and it has like a whitelist of things not to reference. So if like strings and booleans and stuff like that. But if there are complex types, so say like an IDA structure, something like that, then what it does is it replaces the object with a reference, basically a ticket, and then it stores the actual object in a place where it can get it back. So then there's a custom marshalling routine on reference objects, and they're just represented by this 4-byte value that the server uses to look back the object when the client sends it back. So then the server tracks all of these reference objects per session. One of the nice features about IDA is that you can connect multiple clients at the same time, and then all the objects are separate between the clients. Although this can be sort of tricky because the way, maybe I'll talk about it a little bit later, but the way IDA does some of their memory management doesn't really make it possible to have multi-user setup, because there's a lot of functions that will internally allocate stuff into a static buffer and then return you a pointer to it. So if two independent people call the same function, the data is going to get overwritten because IDA is just reusing one thing. So I designed it so in theory, multiple people could be using this, but it turns out that doesn't really work because of the limitations of how IDA does that. So the client, when the client gets back any reference object from the server, it attaches a session to them, which is basically just a channel to contact the server. So in the case of a normal thing, this will just be like a TCP socket. So basically, you end up having a reference object that also has a member variable that's the TCP socket. So then you can just call methods on the object, and then it knows how to go talk to the server. So then implementation details, but it gets caught with method missing, remotely dispatches. And one of the nice things is that because the session object is tied to specific reference objects, you can have multiple connections to different IDA servers and stuff like that, and I'll demonstrate something like that. There's some issues with garbage collection, because obviously if a client has references to objects on the server has no way of knowing what objects the client's referencing. So basically, it leaks memory until you disconnect, and then it everything. So some actual demonstration, because that was really boring. Does anybody have any questions yet? Okay. So I'll just open a random IDB here. So this is IDA, and then I can just launch my plugin, and then I can just start the server, and then you can get started on localhost port 1234. So I'm just in an interactive Ruby shell right now, and then I just connected to the server. You can see in IDA accepted client. And now I just have an IDA object that I can call functions on. So I can say like IDA.screen EA, and that will tell me the address of the current like cursor position. So you can do whatever IDA like get cursor, and it will return the 12.7 or my X and Y coordinates, stuff like that. So basically, this is, it's pretty simple to see, but so what's happening is that this IDA, you can actually see, this is a reference object that references the IDA class on the server side. So then any calls to here get caught and get dispatched to IDA, and then the responses get brought back. So if I call a method that like doesn't exist, you can see undefined method. But if you look, this is actually in plugin receive. So this exception actually happened on the IDA server side and then gets translated back over to the client. So it doesn't look like much when you actually use it, which is sort of the idea. But anyway, so that's basically the general use. So some other cool stuff you can do. So one thing is really nice. The thing I found most nice about IDA is just being able to sort of like play interactively with the IDA SDK, because sometimes it's not always clear how to achieve something. So you can do stuff like give me all of the methods in IDA. And then I can say like, I want to grep for things that deal with byte. And I say like, you know, is byte, do byte, or maybe I want to like patch. So patch byte, patch word, patch long. And then also I can figure out like what methods or how many arguments it takes. So I say IDA patch byte. It says wrong number. You gave me 0 arguments. I expected 2. So obviously patch byte is going to take like an address and then the byte to patch the new value. So it's pretty nice just to be able to like interactively query IDA and then like grep for stuff, because the headers are sort of really hard to get all the information out of. So this is, you know, so I showed the exceptions are proxied. And then also, in order to access constants, you can say like ida.badaddr, which is all Fs. So this constant access is also proxied to the server, so that the client doesn't need like any of the constants. So the client doesn't need to know like what badaddr is and stuff. It fetches it from the server. So the client's really thin, which is pretty nice. Okay. So then, and it takes more work to make IDA still usable while you're running the server. So IDA is single-threaded and it's not thread-safe. So you can start another thread in IDA, call some functions, but chances are there's going to be like a lot of race conditions, and it's just not like a reliable way of doing this. So there's a few different approaches that you can take. But what we ended up doing is we need our RPC server and the GUI to share the same thread. So that's the easiest way to do it. So how we did this is you create a hidden window and then a handler, and then you use a Windows API called winsock async select. And basically what happens is when there's any network activity on a socket, it's like a select, but then it creates a message to a given window, and then our handler handles it. And that will all happen in the main GUI thread. So when you start the IDA plugin, it's going to create a hidden window. We call it the control window. This window has a window handler, and then we set up select on any sockets we have, for example, the server socket. Our plugin returns, and as far as IDA thinks, we just had a plugin that ran for like 1 second, and it thinks we're completely done. But when there's any messages on the socket that we set up the select for, a window message will get sent, and IDA will process this message in its GUI loop and dispatch it to our handler. So we sort of have an interrupt-driven IDA interface. So whenever we have network events, we have a way of processing those network events inside of the same main thread that IDA is running in. And this is basically what you have to do in order to be able to call IDA SDK functions without blocking the GUI thread indefinitely. So this is a really bad diagram that you probably can't see anyway. But basically the way that this entire process would work is a user would call like new client. It would connect on the network. It's going to send a window message to IDA. It's going to get dispatched into the C portion of the plugin, get dispatched into the Ruby portion of the plugin. And then it's going to return back the front object. And then you're going to have this front object, for example, IDA. And then you're going to call a method on it. It's going to marshal all the arguments over. It's going to create another window message, get processed in the C part of the plugin, processed in the Ruby part of the plugin. The method's going to get called by a swig. All the arguments are going to get marshaled back, transformed to reference objects if they need to be, sent back over the network, and returned to the caller. Pretty exciting. So a lot of considerations with this design. So one is that there's a very high latency for any function call you're going to make to the IDA SDK. So because we have to go through this whole step of you marshal all of the data, you send it over the network, causes a window handler, gets processed. So you can basically sort of think of API calls to IDA like you would think of like system calls or something like that, but even slower. So you want to try to do things that minimize the number of API calls. But IDA was obviously not designed to be have high latency method calls like this. So the functions aren't designed to do like batch operations. It's pretty much like it's common to have to call tons and tons of methods in like a loop to do anything. So it's kind of unfortunate because your plugins can potentially be really slow because it has to go over the network for all these calls. So one alternative you could do is you could write specialized functions on the server side that do batch processing. So basically you give it like a list of tasks to do and then it would do them all and then return back the list of results. And this would help with the latency. But since it also supports executing scripts locally, and then obviously you're not running over the network, you can do that too. So basically if you have performance critical scripts, you can just run them locally, and otherwise you can run them over the network. That works fine. So in terms of security, there isn't any because we have this generic RPC mechanism where we can just call any methods on any objects inside the interpreter. So there's not really any protection. And there's no password or SSL or anything like that. So if you expose the IDA service on the network, then anybody can run commands and do whatever, execute code. Does anybody have any questions on that part yet? Sorry, these details are all really terribly boring, but the plan for the future is, so I spent a lot of time, I sort of glanced over a lot of these details because there's just a lot of pieces that were just very implementation like details, like, oh, you know. So I spent a lot of time working on like the foundations to make it really reliable and generic and stuff like that. So, but I haven't actually written that many IDA scripts. So I'm starting to try to do. And then also there was another person who was working on a higher level API for IDA. So there's someone who's not me, some guy who I don't know very well, released this like API on top of IDA that allows you to have more Ruby-like access. So I don't have any higher level APIs, but someone else does. And I started to work on something called IDA utils, which is like IDA utilities, and there is some like higher level access for certain types of stuff. Another thing is right now the network protocol is basically just serialized Ruby objects, but there's no reason why the network protocol couldn't be language independent. So if I wanted to make it like XML RPC or something like that, and then Python or any other language could use the same backend. So finally some demos. So I think it's time to do some sweet graphics because, all right. So I'll start up with something I hacked up quickly. So basically the way these scripts work is pretty simple, but you just call like idarub.autoclient, which will automatically parse the command line and figure out like the host name and IP or the host name and port, and then that returns an IDA object, and then you can just call any method that would be in the IDA SDK on that IDA object. So I call like get screen EA to get the current address and stuff like that. So this is a pretty simple script, and then let me run it. So this is a brickout implemented in IDA, and I'm actually using the cursor inside of IDA to move around the brickout. So I don't actually do any reverse engineering, so oh, I got it stuck. Anyway, I need to work on that. All right. So what else do I have? So basically, the way that works is since this is being interrupt driven, I can still use the IDA GUI while scripts are running, because the scripts are they're only interrupting IDA to run when they need to. So basically the way that works is I just made a little breakout game, and then I just like generate the string for the screen, and I just push all of the frames to IDA in a comment. So you actually can see it. It's pretty simple. So you just say like, string is for the thing, and then I just set a function comment with the string. So I just do this in a loop. And then I also, you can see I call ida.getCursor. So I just query the cursor position every move, and then based on where the cursor is, you can see I'm moving it around. That changes where the pedal is. So yeah, that's how that works. So it's pretty simple, and that's kind of the cool part about it, is that all of this code, you can do stuff like that. Some other demos. So I think there's a few unique ideas in IDA that make it particularly useful. So one of the things is collaboration. Both the server and the clients were designed so that a client can connect to multiple servers or connect to the same server multiple times, and a server can be connected to by multiple clients. So this allows things like have one script that connects to 5 different servers and then does some sort of collaboration. So one example of this is maybe you want to port some comments between one IDB to the other. So a simple way you could do this is you have one IDA script that connects to 2 different instances of IDA, and then you just scan for the comments in the one and port them over to the other. So you could extend this to do some sort of like IDA sync type thing. So I have a little example set up here. So this is just a database where I have some comments here. And then the same database, just without the comments. And then I'll start the server here. Oh, oops. I'll start a server here. So now I have 2 different servers, one running on 1234 and one running on 1235. And then I wrote this really small script that will port the comments between the 2. So, and I have a little shell script that I just sleep for 2 seconds so I can switch over to the Windows. And then I just run comment, telling it to comment between those 2 different databases. And then you can see that it scanned and then ported the comments over to the second window. So you can definitely do stuff like that, which can be pretty useful. So you could say like, okay, I'm working on analyzing one piece of code. Someone else is sharing the same piece of code. Now I want to connect and synchronize like the names of our variables or synchronize comments and stuff like that. So the collaboration aspect, I think, is pretty important. Another thing I think is pretty nice about it is being able to integrate it. Since you have a way of calling IDA remotely, you can call IDA from any environment. So you can call it from, like a Solaris box or something. And you can just write scripts that you can just pass command line arguments and get the values back. So it makes it really nice for just being able to integrate into other stuff. So here's an example that I did after seeing PyMay, was that it's really useful, and Luis talked about this too, but being able to integrate debuggers and disassemblers and stuff like that. So a few lines of Ruby, I wrote up this script that will debug something and then resolve the data dynamically. So I'll show that. So this is Minesweeper. And then the idea is that there's this data section in the executable which is uninitialized data, so it's not stored in the binary at all. But obviously there's going to be values at runtime. So what I'm going to do is I'm going to make a script that debugs a WinMine process interactively and then allows you to query these values and set them as comments. So I'm actually SSH'd into my OS X laptop here, just to also show the network aspects of it and stuff. So I just this little resolve data script that just goes through and connects with uses an interpreter to connect to to debug the process and then query the data. So it's pretty simple. Okay, so start here, and then I will run a copy of Minesweeper, and then what I can do is I can say resolve data, and then you see it connected the WinMine process at PID 2888, and then it found where the IDA cursor was at that address, and then what the value of it at that address is, and then it sets it as a comment. So I can just do this again, and I can go through and resolve data for any of these values in a live running process. So that's sort of some ideas for doing debugger, IDA interaction, and stuff like that. So all of these comment values are coming runtime from Minesweeper. So if I close it, see, this is going to break. So anyway, so that's one of the ideas between integration. When you have this sort of taken out of IDA and just callable from a script, you can start interacting with all different pieces. I could have like a Python script that calls some Ruby stuff, and then it makes it a lot easier. And I have some other examples for that. So one really cool thing is I whipped up this quick GDB integration. So it's just some GDB init hacks and a few lines of Ruby, and it builds to IDA link. So I will demonstrate that. So this is just /bin/ls on OS X. So go over here to the beginning, and this is the entry point. So I'll set my cursor up here on the beginning of the program, and then I will type gdb bin ls after I start the server. Okay. So I can type IDA break, and it queried IDA and found that the cursor was at 1C32, and it set a breakpoint there. So I just set a breakpoint wherever the cursor was. Now I can run, and now I broke on that instruction. And so now, I'll move this over here. So I can type IDA step instruction, and it will step to the next instruction, and then tell IDA to follow along. So you can see the yellow cursor is following along as I step through this code. And then I can IDA comment and say like, blah, and that will set a comment at the current instruction, or at the current line I'm debugging. So I can step again, and then say something else. So this is really tiny amount of stuff, and it's actually pretty useful to be able to, because the hardest part is, so now I'm like, say I'm going to step into this call. It's really nice to be able to like just, keep on stepping through all of this stuff and having IDA just follow along. So, and the way that's implemented is pretty simple. There's just this GDB init script, and it just shells out to a little Ruby wrapper, and then that's oops, and then that's just like this much code. So, in pretty much GDB star, in 51 lines of code, you can write, and it's including the GDB wrapper and the Ruby script, you can write a little bridge to bridge GDB and IDA together. So you could do the same things. And by the way, this is on Darwin, so you can see it's happening over the network and all that stuff. It's pretty cool. So another thing I did, which I'm not going to demonstrate because it doesn't really, it's not that interesting to see happen, but I wrote this thing called, which was used for getting interfaces for Microsoft RPC functions. So it was like, 3.3 thousand lines of code, and then I basically just wrote a small adapter to interact with IDA-rub, because before it would just take a DLL from the command line and then do everything internally. And instead, I just backed it to an IDA database, and then you can add comments and all that sort of stuff. So that's another place where integration is really nice, because now with 80 lines of code, I can just sort of talking with IDA instead of talking to the file system, and then I can add comments and all that sort of stuff. So then this is just on the topic of how you can still interact with IDA while the plugins are running. So for example, I want this. I have this script that calls Blink. loop, setting a comment on and off, and you can see I can still like scroll around and blah, 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 like while it's going. So if you want to have really annoying IDA databases that say like, I don't know. So another cool thing about this is that, like I said, IDA supports multiple clients at the same time. So I can go crazy with a bunch of blinks up in here. And then, so you can see I have multiple clients at the same time. These are all separate scripts, right, all running. And do stuff like that. Also, there's the much improved version of Blink, which is the marquee. And I can throw in some blinks and that shit on top of it. So it's like the GeoCities of IDA. So that's sort of to give you an idea of, so I mean, it may not obviously be clear. So one of the nice things about being able to still interact with IDA and be able to talk to it at the same time is that you can have like an interactive shell, and then you can basically be working in IDA and working in a shell and sort of doing stuff like that. But also you could have scripts that sort of stay in the background, like, query something every minute and see if something updated or something like that. So you can sort of have jobs running to do different sorts of stuff. So you could have something running that's talking to a server, and then when it gets a new message that like you should update a comment if you're writing some collaboration tool, and then it can do that. And it doesn't affect using IDA. So normally when you run an IDA plugin, it just pops up this box saying like the plugin's running, and you can't use IDA at all. So, so none of my scripts actually do anything related for reverse engineering. So this is just sort of a joke because they're all flashy stuff. So then something else is, so this is a game of life in an IDA comment. And the way this is just working is I just wrote a quick game of life board, and then I just push the frames to a comment, and then sort of goes on. So then I also had a pre-prepared board for something cooler. So I set up a glider gun, so you can sort of get some glider gun action going on. And then I had a few other demos. Oh, this is never gonna end. So I did this. Okay. So one thing I actually did that was really handy and was a good use of IDA rub and actually did involve reverse engineering is if you look at any OSX binaries, for example, I will take ls. Do I still have it open? Yes. So if you look at the way they do this, all OSX binaries are compiled with fpic, so all of the code is position independent. So if you see this call instruction right here, all it does is it takes the value of the next instruction and puts it into EBX, and then all of these addresses are relative to EBX. So basically, all of the data accesses are relative to the current function. So it just basically gets EIP and then addresses everything relative to that. So IDA knows any of the references from these because they're all. I mean, IDA doesn't understand the code, so it doesn't know what's going on. So all of these addresses are completely useless because they're just relative to EBX and we don't know anything about it. So I wrote this little script and also demonstrate the local mode then. So if I run the plugin again after it's already running, it just gives you the option to stop it. So I'll stop it. So then I wrote this little thing, reverse engineering parallels. Yeah. So I just wrote this little code that walks through, and it will find all of these get EIPs and then calculate all of the addresses and then fix up all of the references for you. So if I run this, I can select, instead of starting a server, I can select to load a file. And then I can pick this convert offsets. So then what it does is I just name this function fredder EBX and it knows how to find it. So then I click OK, and it finds all these functions that called this thunk, and then it will update all of the EBX relative addressing to actually be the absolute address. And then you can see we actually have all of the names and addresses. So this is like Mach-init routine, this was the environment pointer, and this was argv and argc, stuff like that. So, and it did it for the whole database. So you can see all of these places are fixed up. Let me find some other examples of it. But and that was pretty simple to do because, I mean, it wouldn't have been a hard thing to do in C++ either, but I mean, it's a really simple script, and it's nice just to be able to do that sort of stuff while you're working on a project. So I'll close this. And then another thing is I was doing some OS X stuff, and for Objective-C binaries, I don't have a copy of this. I wish I did. But you basically, the disassembly is really rough because, well, number one, this is PPC, so you have, it's a bit different. And all the Objective-C calls are done at runtime, and so there's not really any information. So I wrote an idarub script that will just go through an Objective-C binary, and it will, all of these names were generated by the script. So like message share instance, class reference preferences, message set serial number. So yeah, that's another thing that was really useful and really easy to do. I just sort of, walk through, and then you can set all of these names to actually what the values are and stuff. So if you do any OS X reverse engineering, this is really helpful. Yeah. So I think that was pretty much all I've had for the demos. It's not that exciting because it's basically stuff you could do in IDA from the beginning. It's just making it easier to do. So it just allows you to write simpler scripts and stuff like that to sort of hack stuff up. But so I have 10 minutes left for questions if anybody has any. Yeah.
Why do you use Python?
Yeah, I know. I'm trying to think there's actually a good reason not to do. Well, some of the RPC stuff I wouldn't actually know how to do in Python, but I imagine that you could do the same sort of stuff. Someone talked about maybe trying to do the network dispatching stuff in IDA Python, but I haven't seen anything about it. But any real questions? Anybody want to see those again? More games of life? Each board's unique. Hours of fun. All right. Well, that's it then. Thanks.